Hello, welcome all. This presentation delivers a mitigation technique for cyber attack in a power system environment. A low-cost Raspberry Pi based estimator is proposed to estimate the false data injection type cyber attack to the sensor data that are being transmitted using communication infrastructures. In this work, a two-area power system is taken as the test environment. Here, two-area power system is formulated using Simulink. A group of coherently operating generators forms an area in power system. In areas, governor turbines and the generators are operating to deliver power to the electrical loads. Upon certain perturbation, the generators needs a change, which is decided by the controlling action of the controllers. The controlling action is decided by processing the system information perceived through the phasor measurement units. The measurements like frequency of areas and the tile and power are sent through communication platform. This sensor unit provides highly precise data transmitted through communication infrastructures. These communication stages make the whole control operation vulnerable to cyber attacks. False data injections are very critical as they alter the sensor data that are being delivered to the control center. This lead or can lead to instability and blackout in power system. The estimator takes the sensor data to predict upon the attack signals that may exist. The system matrices are provided to the optimization problem created to formulate the estimator. The LMI solver in robust control toolbox synthesizes the estimator matrices by processing the system informations. These matrices creates the state space model for the H infinity estimator. The estimator will be designed using the Simulink platform. After designing the estimator model in Simulink, the estimator will be deployed in Raspberry Pi 4 board. The deployed estimator will wait for the sensor signal to arrive so that it will estimate the cyber attacks. Two-area power system will be running in simulator using MATLAB desktop real-time service provided in Simulink. The sense frequency and tile and power deviations will be informed to the estimator using TCP/IP socket protocol. TCP/IP provides reliable and secure data communication between the two devices, that is the power system and the Raspberry Pi, using the Ethernet link. The sensor data and the control commands will be transmitted through the TCP/IP protocol using Ethernet link. For validating the performance, cumulative attack consisting of step and sign signals is introduced to the area frequency 1. The attack signal is represented as A1 here. The corrupted sensor data transmitted through the TCP/IP communication will be received at the estimator running in the Raspberry Pi board. This corrupted data will be sent to the estimator using the Ethernet link. Upon processing this data, the injected attack signals are predicted. These predicted data are transmitted using the TCP/IP protocol. The TCP/IP protocol transmits this data back to the power system. Upon receiving these estimated signals, the power system will compensate for the cyber attacks. From figure 1, it is clear that the attack is estimated correctly. From the next figure, it is compensated to the power system and the performance improves after 20 seconds. So The Raspberry Pi based estimator performs well enough to mitigate the effect of cyber attacks. For further studies, power system considering more areas can be considered to improve the practicality. Also, non-linearities like reheat turbines, deadband zones can be taken into considerations. Delay modeling also remains unexplored in this work. Finally, a low-cost estimator deployed in Raspberry Pi 4 is proposed here. This estimator is found to be capable of handling false data type injections to the power system. Thank you all.